Hello everyone, myself Professor Tushar Gujarati from S.N.D College of Engineering Yeola. Today we'll study the experiment number 9 from the subject Mechatronics, and the name of experiment is PID control implementation on DC motor speed control system. So what we are going to do here, we are going to implement PID controller for controlling DC motor speed. Okay, so we have to control here speed of the DC motor. So this you remember. Now the objective of the experiment. What is the objective? To design and tune a proportional integral derivative controller for precise speed control of a DC motor. So we have to tune PID controller, proportional integral derivative controller. So here, what is the meaning of tuning? We have to set the values of PID constants in the instrument or in the setup or in the controller. So the controller has inputs that we have to give in the form of Kp, Ki and Kd. Okay, this is the objective of experiment. Now what is the outcome of experiment? First point, understand the working of DC motor. So first of all we have to understand working of DC motor. Then second point, design a PID control algorithm to control the speed of a DC motor. We have to design a PID control algorithm to control speed of DC motor. And third one, discuss the effect of P plus I, P plus D and P plus I plus D controller on the response of the DC motor. So we have to discuss the effects of different controllers on the response of the DC motor. Now this is the DC motor. So this is simple electric motor. So I think you all know this working of DC motor. So what is here? There are two magnetic poles are provided, N and S, north and south pole. So in between them one coil is placed, coil or it is called as conductor is placed. Okay, so through this coil or conductor current passes. So the electric current passes through these coils. Okay, so at the end of this coil or conductor, what is shown here? Here brushes are shown. So brushes are provided over here. Okay, and through this circuit the electric current flows through the coil. So you know the working principle. What is working principle of DC motor? If current carrying conductor is placed in magnetic field, okay, so what happens? Forces are developed in the current carrying conductor. So here what happens? Forces are developed. This arrow shows us force. So like this, force or motion is developed in the current carrying conductor. Okay, so like this the coil or conductor rotates. So if you connect this conductor to the shaft, okay, so like this shaft will rotate. So like this working of the motor is there. So you should understand the principle. When current carrying conductor is placed in magnetic field, what will happen? The current carrying conductor receives some forces. Okay, so these forces makes it to move or rotate. Okay, so like this it works. So now we have to control speed of the DC motor. So here this is the feedback system is shown. So this is DC motor. Okay, we have to control speed of DC motor. So you tell me who will control the speed of DC motor? So we will require PID controller. So PID controller will control the speed of motor. Okay, so we are going to set here desired speed. What is our desired speed? 500 rpm is our desired speed. So from output side we will measure the output speed, that is measured speed. Okay, it will come here. So now in this block summing point, the desired speed and measured speed are compared. Okay, desired speed and measured speed are compared and error is generated. So this error is input to this PID controller. Error is input to this PID controller, and PID controller then sends control action to this DC motor. Okay, PID controller sends control signal to this DC motor, and according to this DC motor either increases its speed or decreases its speed. Okay, so like this PID controller works. So now what is important here? We have to tune this PID controller. We have to set here values of Kp, Ki and Kd. So these are all constants of PID controller. So values of setting of these values Kp, Ki, Kd is called as tuning of PID controller. So what is procedure here? Connect the PID tuner to 230 volts AC supply. Okay, then turn on the main supply and observe self diagnostic tests. Okay, then third point, ensure no error while self diagnostic check. So there should be no error, then we can go for readings. Now set appropriate PID constants. Okay, set output percentage to be 100%. Now set proper set value. Now set value is nothing but input value or set value, that is suppose 500 rpm is our set value. Okay, now select the controller mode. Refer the PID controller mode selection chart. So some charts are also provided for selecting PID controller modes for respective speeds. Okay, now note the observations. Give step change to set point value and repeat from step 8. Okay, so like this we have to note down the observations. So precautions are also very important while taking an experiment. So first precaution is ensure that the PID turner is connected to 230 volts AC main supply. Okay, ensure no any error detected while self diagnostic check during power on. So second step, there should not be any error. Now third step, ensure the proper mode of control action is selected. So you should ensure that you have selected proper control actions. Next, ensure the proper PID constants are programmed. And last point, ensure the proper set point is programmed. So these are all precautions that we have to take. Now PID controller mode selection. Okay, so first one is on off control mode, which continuously makes on off. So in this case PID values are 0, P is equal to I is equal to D is equal to 0. So it is not controlled, actually it is only on off control mode. So PID values are 0. So now proportional controller. So in the proportional controller, second case, I and D is equal to 0. Only we have to enter value of P, and it is also between 0 to 200%. Okay, proportional control band, that is called as proportional control band, 0 to 200%. Okay, now third one, C point, it is PI control. Now what is PI control? Now P is equal to M means moderate value we have to take. I is equal to 0 to 3600 second. So this value we have to select from 0 to 3600 second, and D is equal to 0. Okay, like this PI controller works. Similarly PD control, if you take PD control, then you assume that P is moderate. Okay, and D is from 0 to 900 seconds. Value of D varies from 0 to 900 seconds, and I is equal to again 0. So like this PD controller works. And what is PID control? PID control, we have to enter all the three values PID. Okay, so these values may be moderate. PID is equal to M. Okay, so here moderate constants I have shown here below. P is equal to 30, I equal to C, and D equal to 2. 36 and 2. So like this we can select control modes. So now observation table will be something like this. We have to set value, right? Okay, there will be some set value, like suppose 500 rpm. Okay, this is our set value. Then for every time, suppose you can take for 10 seconds or 1 minute, 1 2 3 4 5 6. So every minute you can see the process value. What is process value? Whether it is 499, whether it is 505, whether it is 510. So whether the set value is controlled or not, that we have to note down here, process value. Okay, and after that you should note down, or you should plot the graph between speed of motor and time. Okay, so this graph you have to plot, and from this experiment we found the conclusion that in this way we find out the method to select PID control parameters and to control the speed of DC motor. So in this way we find out the method to select PID control parameters, how we can select PID control parameters, and how we can control the speed of DC motor. This we understood. So thank you so much friends for watching this video. Thank you.